Let's solve a trigonometric equation here. So we have 2 sine squared of theta minus 1 equals 0. And we want all the solutions for theta that lie in between 0 and 2 pi. So basically the first time around the circle. So as we get going on this, we really want to isolate the sine of theta from the beginning. So some students struggle on doing this and visualizing everything with sines involved. This problem is very, very similar to the problem I'm writing over on the left-hand side. So what I've done is I've replaced the sine that was squared with a y that's being squared. If we can solve this down for y, it's going to be basically the same steps as far as solving this down for sine. So let's work this side problem first and show you the steps, and then we'll work this one next. So we have 2y squared minus 1 equals 0. I would probably first go ahead and add 1, move that to the other side. My goal here is I want to make this into a power equation, isolate the y squared on this particular one. So the next thing I would do is go ahead and get rid of that 2. By getting rid of it, I mean divide both sides by 2 and move it to the other side. So this will produce y squared equals 1/2. Now to get y by itself and to eliminate that square, I would apply a square root to both sides. Now, because we applied the square root to both sides, we want to include a positive and negative case. So that'll put y on one side by itself. And then I'm going to also go ahead and say, well, I can put a square root in the numerator and in the denominator. So that'll be a plus or minus 1 over the square root of 2. I'm going to rationalize this by getting rid of the square root from the denominator by multiplying numerator and denominator by the square root of 2. Now, a couple of reasons to do this. One is, mathematically speaking, that's going to be a little bit better answer, not to have a radical in the denominator. But the other reason is square root of 2 over 2 is one of these ratios that probably comes up pretty often as you've been working with trigonometric functions. So we want to kind of locate common ratios that show up a lot. That helps us as we're trying to solve these down. All right, so far I've had y's involved. I want to go back to our original problem and work through these same steps just to show you not much has really changed, right? I'm going to add the 1, move it to the other side. That'll give us 2 sine squared of theta equals 1. I'll divide both sides by 2. That'll produce sine squared of theta equals 1/2. And then to get sine on one side by itself and get rid of that square, I'm going to apply a square root to both sides. Don't forget the plus and minus. So that'll give us sine of theta equals, it'll be the exact same reducing down. So I'm going to go ahead and use that work we already did and get to plus or minus the square root of 2 over 2. Now, hopefully you're saying to yourself, well, square root of 2 over 2, that's one of these angles that shows up, one of these ratios that shows up quite often. I'm going to go ahead and designate the angle that would produce square root of 2 over 2 with theta bar. I'm using the bar because we're going to use this as a reference angle, and that's pretty typical notation. So pi over 4, if I substitute that into sine, is going to produce square root of 2 over 2. Now, this does include a positive and negative, so we want to be a little bit careful about that. So let's think this through. I like using the phrase all students take calculus to remind myself which quadrants things are going to be positive in. All of our trig functions are positive in the first quadrant, only sine in the second quadrant, tangent in the third, and cosine in the fourth. Now, in our case, because we have both positive and negative, we can find one angle in each one of these quadrants that's either going to produce a positive square root of 2 or a negative square root of 2 over 2, I should say. So in the first quadrant, that's the one that we were thinking of, this pi over 4. So if I place that in the first quadrant, theta can equal pi over 4. All right, in the second quadrant, what I would do is I would use that pi over 4 as a reference angle into the second quadrant. And then I want to calculate the angle that wraps from the x-axis going out to the right-hand side all the way around here and lands here in the second quadrant, where pi over 4 is going to be the reference angle for whichever one I'm going to calculate here. So our quadrant 2 solution is going to be calculated as theta is going to equal, remember it's pi to go halfway around. I'm going to take pi and subtract away pi over 4. And that'll be the angle in the second quadrant. So a little bit of work to get a common denominator. I'm going to think of this as 4 pi over 4 instead of pi, minus pi over 4 is going to give us 3 pi over 4. So that's going to be our solution in the second quadrant. Remember, pi over 4 was our solution in the first quadrant. Next, we had the positive and negative. So in this case, it would be okay to place our angle into the third quadrant and into the fourth quadrant. So again, kind of visualizing what's going on here. If I place pi over 4 as our reference angle into the fourth quadrant, let's think about that calculation. Sorry, that's the third quadrant. I think I said fourth. Quadrant number 3 down here. What I would do for our calculation is it's going to be pi plus pi over 4. And this time we're looking for this angle that wraps all the way around into the third quadrant. I would say our theta is going to be given by pi plus pi over 4, because it's pi over 4 further than going pi around the circle. So again, common denominator 4 pi over 4 minus pi plus pi over 4 is going to give us 5 pi over 4 for our solution in the third quadrant. Now, when we plug this into sine, that would be it would equal the negative square root of 2 over 2, which is okay. One more calculation here. We want quadrant number 4. So this time, if we place pi over 4 in here as a reference angle, last one we want to do is calculate if I wrapped all the way around into the fourth quadrant, what is that value for theta going to be? Well, how I do this calculation is, remember, it's 2 pi to go all the way around the circle. So I go 2 pi, and I want to subtract away pi over 4. Because pi over 4 is our reference angle. This time we're going to go 8 pi over 4 is equivalent to our 2 pi, just with that common denominator, minus pi over 4. It's going to give us 7 pi over 4, an angle in the fourth quadrant that when we plug it in to sine, it's going to produce a negative square root of 2 over 2. So we found all of our solutions between 0 and 2 pi that are going to make true statements when we plug them back into this original equation. Hope this helps out. I know finding reference angles can be a challenge, or using those reference angles in each of the quadrants, but keep up the practice. You're getting there. Good luck.